how did this green graph shift from the original blue graph?
It shifted left by 4 units and down by 5.
Perfect. Left 4, down by 5. Okay. So if you're writing this out on notebook paper, just write that sentence down real quick next to this function. Make sure you have a sketch of the graph. Okay, we're going to run through the last two pretty quickly. We're not going to graph them, although you are welcome to. I will graph them on Desmos so that you can see them. We won't draw them out on our paper, though. We have x minus 1 quantity squared plus 6. Okay, so this is our function. For the next one, we can click to find the vertex on Desmos. So for this problem, Brandy, are you there?
I'm here.
So what should my vertex be for this function right here?
1, 6.
Perfect. 1, 6. And it shifts. How did it shift from this original?
It shifts right by 1 and up by 6.
Right 1, up 6. Perfect. Thank you very much, Brandy. Okay, so just jot this down real quick. This function is vertex and how it shifted from the parent function. Eddie, are you there? Eddie? Eddie, are you there? Eddie, if you are there and you're just having technical issues, call or send me a message on Remind so that I know. Okay, so let me find.
If you don't mind me asking, I never got the Remind code.
Yes, it's on our homepage and it's on the teacher information page. You can sign up on both places.
I bet.
All right. Asai, are you there?
Yeah, I'm here.
All right. So next was this 3 times x plus 7 quantity squared plus 2. What is the vertex for this function right here?
-7, +2.
Perfect. -7, +2. And can you tell me what the shifts are for this function?
It shifted left by 7 and then up by 2.
Left 7, up 2. Perfect. Thank you so much, Asai. Okay, so from this section of the investigation, from doing all these examples, there are some things that we can generalize about our function. Okay, so that's what we're going to put in this gray box down here. All right, so if you're writing this out on notebook paper, these sentences are vital. These are the most important ones. So it says in the equation y equals x plus h quantity squared plus k, the vertex will always be -h, comma k. Okay, so no matter what you have, that will be your vertex. What questions do you guys have? Okay. Then it says the graph shifts left if h is positive and right if h is negative. So if I have a negative sign right here, it's going to shift to the right. If I have a plus sign, it will shift to the left. Okay, so it does the opposite of what you think it should do. Then it says the graph shifts up if k is positive. And the graph will shift down if k is negative. Okay, so everybody should be writing this down. These are the really important things that you will need to remember. When you are writing the vertex, remember to split the sign of H. Okay, so when you're writing the vertex, remember to flip the sign of the H value. Okay, so all this stuff is super important. This section must be written in your notes. Okay, and you guys are submitting this, or you should have already, so please make sure that all this information is written down and I can see that you've done it. Okay, on Thursday, we went through what each of these variables represents. We talked about how A stretches or compresses the function, how H shifts the function left or right, and how K shifts the function up or down. Okay, so you should have all that written down from Thursday. All right, I'm going to go ahead and flip the paper. Are there any questions before I flip?
Hold on. Okay,
We're going to go ahead and flip now.
are we supposed to do the back also?
Yes, you were supposed to finish the entire thing. Okay, we're just going through it together to make sure you understood what you did. All right, so the first thing that this asks you to do is graph the function y equals x squared. We should be pros at this from the front side. Okay, so we're going to just sketch in real quick. And then it says in step 3, in a different color, graph y equals negative x squared. So if you're not sure what that looks like off the top of your head, just run over to Desmos real quick and type in y equals negative x squared. Okay, so this looks like the exact same function. We just flipped it over the x-axis. Okay, so I'm going to go ahead and graph that in green. What am I doing? 2, 1, 2, 3, 4. Okay, so you should have something like this for y equals negative x squared. Does this graph open up or down, the green?
Down.
Very good, thank you. Okay, so this graph is going to open down. In step 4, it says using a different color, graph negative 3x squared. So if you aren't sure what that looks like off the top of your head, type in y equals negative 3x squared. Okay, and we get this shape right here. I'm actually going to go ahead and keep in my negative x squared because I want to see the difference. So my negative x squared was this red quadratic function. Do you guys see how it's fatter than the black one? Okay, so this new function is flipped and it's the same, except we have a much skinnier graph inside of there. Okay, so if we look at this graph, it also opens down. Okay, but the difference here is that it's a little bit skinnier. So it asks you to do a few more. If you graph 2x squared, I'm going to go ahead and, whoops, I clicked on something I didn't need to. Hold on one second. Let me get rid of this. Okay, so I'm going to go ahead and I'm going to graph what it asked me to. It asked me to graph y equals 2x squared. And it asked me to graph y equals negative 2x squared. And we're going to compare it. So no matter what the number is in front, if I flip the sign, it's going to open the opposite direction. Okay, so the blue one opens, let's see. Jukai, are you there?
Yes.
So does this one open up or down?
Up.
Very good. And will you go ahead and do the next one for me? Which one, what does the next one do?
Down.
Perfect. Thank you. Okay, so we've shown through this little section, so this conclusion, remember, is the important part. This is the part of the notes that I really need you guys to have and keep. So in the equation, y equals ax squared, the graph opens up if a is positive, down if a is negative. What questions do you guys have? Okay, if there are no questions, we're going to go ahead and wrap up the last section of this, okay, so that we can talk about today's assignments. All right, so now it asks you.
Can you go back up, please?
I'm sorry?
Can you go back up, please?
Yes, next time if you'll let me know when I ask if there are any questions. Looks like somebody's trying to get in. Well. Okay, so we're going to shift on up. Now it asks us to graph the function y equals x squared. So we're going to go ahead and graph that in just like we've been doing. Okay. And then in step 3, so it says graph, draw the function. You could have graphed it in Desmos if you weren't exactly sure, and then it wanted you to go ahead and draw it. In step 3, it says using a different color, graph y equals 2x squared. Okay. So I am going to, I have it right over here, and I'm going to go ahead and put in y equals x squared, so it's easy for me to compare the two. So my x squared is my purple graph, and my 2x squared is my blue. So when I have the 2x squared in there, it should be skinnier than my original function that I've drawn, okay? So what I'm doing here is I'm taking each of my normal outputs and I'm multiplying them by 2. So when I normally would have had 1 as my output, now I will get 2. When I normally had 4 as my output, wait, did I graph this wrong? 1, 2, 3, 4. Oh, I'm sorry. I did graph my pink points wrong just now. I put them at 3 instead of 2. Okay, so these guys should be at 2. And then when I normally would have 4, now I will have 8. So 4, 5, 6, 7, 5, 6, 7, 8. I'm going to have 8 here. So my new graph is slightly skinnier than my original graph. Okay. So this graph is going to be stretched vertically by a factor of 2. Okay, so what questions do you guys have on that? Do you see how it's stretched out?
Yes.
Perfect, thank you. All right, and then it asks you to do another function, but this time instead of a 2, it asks you to put a half. I'm going to put 1/2 x squared into Desmos. So this is this black function, and we can see that this black function is a lot fatter than either of the other ones. Okay, so we need to figure out how to graph that on our graph. So what this one is going to do